So let's get started with day 4 on Spark. And until now, we saw that basically Spark will have three basic or three data structures or three collection. One was RDD, the another one was data frame, and the last one was a data set. So that this came in 1.x. This was there in 1.6, but more used in 2.x. And this also came in 2.x. I mean, it came in 1.5 or 1.6 and mostly used in the version wherein 2.1, 2.4 or someone is installed. So RDD being very old, it is not used much. Yeah, it is not used. I mean, you should be using data frame or data set. You should not be using RDD. Then again, why we are studying RDD in that case? Most of the place people may skip learning this as well, but it's still more important to for us to understand and learn RDDs because of few reasons. First reason can be some legacy code. So there is some legacy code that was written in Spark 1.x, and since RDD is also supported in Spark 2.x and 3.x, you may need to that code may be running and you may need to support that code. Second thing is if you want a very tight control. When what do you mean by a tight control over here is let's say I am having a particular uh, table kind of a thing, roll number, name, and let's say age 1, 2, 3, A, B, C, 10, 12, 14. So let's say I am having some data that looks like this, and of course, it is spread in a multiple machine. So let's say it is having three partitions. So partition 1, partition 2, and partition 3. For certain reasons, you want that or you want to control that okay, roll number 1 and roll number 2 should never be in the same partition, right? For some reason, let's say because if this roll number 1 and roll number 2 is in the same partition, it may crash the code, right? So that can be one of the reason that you never want it 1 and 2 in a same partition. So if you want to have such a tight control, you can only do this in RDD. You cannot do this in data frame and data set, wherein you control that what part of a data is present in which partition. So this is one of the example. Another example can be, let's say you are doing a bank processing and you are having a something called as an account number and a debit credit field, right? So let's say there is account number 123 debit 12, 123 debit 15, 123 credit 12, and 125 debit 16. So let's say this is another example for a bank, and for this purpose, for certain reasons you want that this 123 account number should be in the same partition. It should be always in the same partition, right? So again, you may need a very tight control that for no reason it should be going in a different partition and so on. So if you need such a tight control, that is you want to avoid or you want to decide which partition has what kind of a data, you will have to use a RDDs, right? So if you want a tight control and you basically want to decide what kind of a data is present in which partition, in that case you need a very tight control, then you may have to use a RDDs. You cannot do such a tight control in case of a data frame and data set. Again, we'll be seeing with an example on how this control can be implemented in next 3 days. So first reason was legacy code. Second thing was tight control. And the third reason was data frame and data set insist are built on a RDD, right? data frame and data set is on top of RDD. So when I say a data frame, which is a collection of this table, it's basically nothing but an RDD only behind the scenes. It's just a collection of RDD. So this data frame and data sets are just a high level APIs on top of RDD. So RDD is also called as a low level API. It is also called as low level API. This is called as a high level API. So similarly, if you do a programming, you never use a low level languages like shell scripting a lot. You only use it when you want to control. And for all the business application, you will be using a high level language like Python or Java or some other language. Similarly, in Spark as well, you will never be using a low level RDD. You will be only using it if you have to support a legacy code, because long back in Spark 1.x you did not had a data frame until 1.5 or 1.6. So even when it came, people were still using RDDs as it was the old thing. So one reason is supporting a legacy code. Second reason is if you want to implement a really tight control, then. And third reason is data frame and data set is itself consists of an RDD. So you need to understand RDD really well so that you are able to basically look into a UI and do certain things on UI. So that is the reason you are able to debug anything, what is the issue and all, so that you are able to understand what is happening behind the scenes. It's important for you to understand RDDs as well. Any questions until now? Anyone, any questions?
No. Nope.
Okay, perfect. So if no questions, let's go ahead. So definition of RDD. So RDD is immutable. It is partitioned. It was used in 1.x, but from 2.x people are not using it. But it is available since 1.x. It is also present in 2.x and 3.x. So it is not deprecated, but it was mostly used in Spark 1.x. Not much used. Not much used. Instead, use a data frame over here, Spark 2.x. So we'll be also using a data frame only, but it's still important for us to uh, do this. Next thing is when you are using an RDD, you will have to do optimization by yourself, right? So you have to do, programmer has to take care of optimization, has to take care of optimization. The simple example being, let's say you want to play with two different RDDs, RDDA and B, RDDA and RDDB, and you want to do a join as well as filter on both the things. So what you will do first? Will you do a join first or a filter first?
Filter
Filter, right? What is the reason?
to optimize, improve the performance and the less data join.
Right. So you're reducing the data in both the RDDs, then you can do a join. So you have to take care of this. But if you are working on a higher level APIs, the Spark will automatically take care. Again, the full form is resilient
Distributed data set.
distributed data set. So what is the meaning of resilient?
It can be recovered.
Yeah, recovered quickly. So able to recover quickly because of all the DAGs and all it may. What do you mean by distributed?
It supports the distributed data system.
Yeah, so it's a distributed, right? So if I say that I am having a certain amount of data that will be spread across multiple machines, right? So it's a distributed, spread across nodes, spread across nodes, right? So it's a distributed, and the data set is for data. It is immutable. So if you have listened to the Spark before, there were two types of variables. One was var and one was val. If I define anything as a var, let's say var a is equal to 5. If I want to check a change a is equal to 6, I can change it. For val, if I define a val a is equal to 5 and I do a is equal to 6, I cannot change it. So this means if I cannot rewrite the value, that means it is called as a immutable. That is, you cannot mute it. Immutable, right? Cannot change the value. Cannot change value or contents, right? And if you are able to change over here, this is called as a mutable. That is, you are able to change. Can change contents. So let's see this quickly. So immutable meaning if you put something inside a RDD, or not even going into an RDD, if we are talking in terms of a just in terms of a Scala, if you are putting something over here, you are not able to change it. Example was a val in case of a Scala. So that's called as a immutable. To see this, you can start a Oracle VM. Uh, Click on Hadoop 2004 Hadoop. Either double click or click on start, and it will start the VM. Or else, okay, let's wait for it to start. Okay, so it is started, and let me start all the things. The steps are over here in start.odt, as well as the steps are also there in the text document, which is having a steps for installation. So start dfs.sh, start yarn.sh, nohub, hive, service, metastore, $spark underscore home, sbin, start dash all dot sh. Okay, so okay, so it is starting. And in fact, what you can do is you can just copy all these commands into a single shell script and also keep it over there. That's fine. Okay. So let's see, let's wait for it for starting. This is started, this is starting, this is also starting. So these are the 4 commands to start. So Spark is also started. DFS is still starting. Okay, so let's start Spark shell. So the first thing that you will be doing is you will be running this thing. So I just copy and change it to sc.setlog level to error. Taking some time because of more load on PC, video sharing and all. So it is saying that web UI is over here. I can open this link. And currently there are no jobs. Spark version is 2.4.4. Other environment details you can see over here. So what is the Java version? Where is the Java installed? What is everything? Where is Spark installed? What is Spark home set? So again, these all things are more related to admin specific, but still you should be knowing some of the things. What are the jars that are available? Okay, so Scala is started. So it's a Spark, and inside Spark it is Scala. So what I do is var a is equal to 5, a becomes 5, and it automatically takes it as an integer because the value that you are putting 5 is an integer. Now if I want to check it, change a is equal to 6, it will work fine because you have set it as a var, that is a variable. Similarly, if you do a val a is equal to, let's say val b is equal to 5, and you want to change it is equal to b is equal to 6 now, then it is going to say that reassignment to a val, right? It says that reassignment to a val. So if it's something is defined as a val or value, you cannot change it. But if you are defining as a var, you can change it. So if you are able to change it, it means it is a mutable. It is a mutable. But if you are not able to change it, it is a immutable. So you cannot do a reassignment to a value. So similarly, in case of RDDs as well, RDDs are immutable, right? So when we'll be starting to see some example of RDDs, you will always see that we are defining the RDD as val, because RDD itself is immutable. So we can still it's always better to define it as a val, because val also means immutable. But even if you define it as a var, it will still work, just that it will give you some warning that uh, you are assigning a immutable kind of a structure, that is RDD, to a var, right? So even if you write var, it will still work, but you should never write a var because it is anyhow immutable. So always give it to a val. So you will always say val RDD is equal to whatever. So the first thing that we need to note about RDD is immutable. That is, whatever is the content inside the RDD, it is fixed. You cannot change the content of the RDD. If you want to change it, you change it and put it in some other RDD, right? So if I want to change something for A, now I cannot change it. Better what you do is you make a val B is equal to 6. Similarly, for RDDs also it is immutable. That is, you cannot change the content of it. The second thing was it was partitioned, meaning it will be stored in a multiple partition. Third thing was Spark was in RDDs were introduced in Spark 1.x, but from 2.x and 3.x it is not much used. Uh, the next thing was programmer has to take care of the optimization. He has to take care of all the optimization he want to do. He has to write the code properly. That is, don't do a join first and a filter later on. It will be more slow. So you should always do a filter, then you should be doing a join, right? Again, we have already discussed on why are we studying RDD, because of legacy code, tight control, and data frame and data set is on top of RDD, right? So let's see next thing. Again, in case of Spark, you are going to do two things. One thing is a transformation, okay, and the next thing was an action. We also saw it a day before yesterday. Transformation and action. So transformation is if you want to transform something, right? Transform, or else I will say you want to modify something, right? Example can be filter, right? Filter meaning where condition in SQL. So if you want to use a where condition, you can use a transformation. The next thing we said about it was it is a lazy, right? So it is a lazy, right? What do you mean by lazy, anyone? What do you mean by
It
lazy?
will not, it will not execute until the action is called.
Okay, good. Causes the execution of transformation. So lazy means transformation will not be executed. Transformation transformation will not be executed until you execute a action, right? So if it sees an action, then only it will do all the previous transformation. Why it was lazy, by the way, we discussed last time.
because of the memory processing.
Memory and all, right? If you don't
Yeah,
make it lazy, you do everything, it will keep the memory hold for more time.
yeah.
Okay, perfect. So transformation and action. So what we are going to do today is We are going to start with the practical. We are going to create some RDDs and we are going to execute some of the transformations and some of the actions on it, right? Okay. So before going to a practical, just let us quickly revise what we discussed so far today. Uh, okay. So RDD came in which version of Spark? RDD came in which version of Spark?
One.
One, right? Is it used from 2.x onwards?
No,
No. Then why we are studying RDD then?
that's because of the legacy code or to understand the output or
To understand the output and tight control, right?
yeah,
So if you want to have a very proper placement or all these things, then you can do at RDD level only. So
yeah,
what you will do is you will be you will work with the data frame. Then you will convert the data frame into RDD, do some tight control, whatever tight control you want to do, then come back again to a data frame, right? So this is the most suggested way. You don't start working completely on an RDD. You can work on a data frame, go back to a RDD, do whatever tight control you want to do, then come back into a data frame and do all the processing again. Okay. So you can convert between data frame, data sets, and RDD and come back again. So you can implement this tight control in RDD, convert back into a data frame. Okay. Next thing we discuss about it is a immutable. So what do you mean by immutable?
cannot be changed.
Cannot be changed, right? Once assigned is assigned. Partitioned, meaning it will be in different machines. Again, RDD was came in Spark 1.x, and the programmer has to take care of the optimization, meaning you have to do a filter first and a join later on. Okay. Any questions, anyone? Okay. Okay. Perfect. Perfect. So if you are not speaking, you can put on mute. Else, once I post this in Udemy, someone is going to put a review that I can listen to child speaking. So yeah, then let's go to the next thing is about transformation and actions. So then we said that we are going to learn about transformation. Transformation meaning transform or modify. Example will be a filter or where condition. And lazy, it's a lazy thing. Lazy meaning the transformation will not be executed unless and until you execute an action. An action is something that causes the transformation to execute, as well as example of action can be save to a file, display on terminal, etc. Right. So these are the example of action. So what we are going to do is in today's session and next two sessions, we are going to see transformations and actions in RDDs. So let me start. Go to this, and what I will do is will execute on a Spark. So let me come out, exit, and Spark shell again. Spark shell. So I just move it to the half side of a screen, and I keep this on the half side, or maybe I keep a Word document on this side. So I make a WordPad, and later on I will be sharing this WordPad with you. So on the right hand side we are going to practice, and left hand side we are going to make a notes of whatever we practice so that you can later on use it. Okay. So I'll just give it as a name, practicals on RDD. So this document will be with you as well. So make sure that you are not just copy pasting into the command line. Make sure you type by yourself. If you do a copy paste, then it's you will not remember for long time. As well as when it comes for you on doing a real work, you may tend to do some mistakes. So it's always good if you type one time. So practical on RDD, resilient distributed data set. Okay, so we'll be creating an RDD. Let me increase the font. I hope it is visible, right?
Yes.
Okay, so the easiest way to create an RDD is using a parallelize method. Okay, Parallelize, parallelize method. So you have to run a parallelize method. So method is nothing but a different name for a function. Okay, so whenever I say a method, you can just consider it as a function. There is just a narrow gap between it. If a function is defined inside a class, it is referred as a method. But people use it interchangeably, method as well as function. So if I say method, method is nothing but a function defined in a class. But you can just think of it as just as a function itself. That's totally okay. Okay. So we are going to create an RDD. So to create an RDD, we have to use a parallelize method. The method parallelize is present inside Spark. Okay. Method parallelize is present Spark, inside Spark dot Spark context dot parallelize. Okay. So the method parallelize is present inside Spark context parallelize. Okay. So this is the method that we are going to use to create a RDD. Okay. It's same as let's say you want to create an array, right? So if you want to create an array, so what is a method you use? You use something called as an array, right? You use an array, a comma b comma c, a comma b comma b. So if I'm creating this array, this is nothing but a function or a method, right? So method is something, a function that is defined inside a class. So if I want to create an array, I use a method as array to create it. Similarly, if I want to create an RDD, I will have to use a method that is called as a parallelize, because it is a parallelize, right? We saw in the introduction, it is a parallelized data structure. So we are going to use a method called as a parallelize, and this method is present inside a Spark. Spark is nothing but a Spark session, and then it is present inside a Spark context. So let's start creating an RDD over here. So I will say that val, and I will say the name of RDD as cars RDD is equal to, and can you give me some, let's say I will make an array out of a cars, and then we will be making an RDD out of it. So cars array is equal to array. Okay, can you give some names of cars?
Names of cars: Bentley.
Don't give a name of a car that I cannot afford and I don't need it also. Is it correct? Bentley.
Yeah.
Okay. Then what else?
Mercedes.
Mercedes. Okay.
The low budget car is Swift.
Swift. Swift is not a brand, right? Maruti, right? Or Suzuki. Suzuki. I mean, just writing a company name.
Honda.
Honda. Okay. More two,
What
three.
else?
Jaguar is a brand, right?
Yeah, Jaguar.
Jaguar is okay.
Mm,
Okay.
how
Mercedes.
many you need?
More two, maybe.
Okay. Uh,
Fiat,
Fiat. Okay.
Citroën,
Sorry. One more.
Citroën,
Audi.
maybe. Audi.
Volkswagen. Volkswagen.
Okay. Audi. Okay, that's fine. So we are having certain cars in an array. So what I have done over here is just define an array over here by this cars. So let's change it to courier name. Okay. Okay. So we have defined an array with a name of an array is a cars array. Now if I want to convert this into an RDD, I can do it as val cars RDD is equal to, now instead of array what shall I write?
sc.parallelize.
Sc.parallelize is the shortcut. Yeah. So you have to write spark context dot parallelize, and then I give a name as cars array. So I am doing a spark context dot parallelize and giving the name as cars array. And let's say I want two partition for it. So I say that I want two partitions. So what this will do is this is going to create an RDD for you that you can see over here. The name of RDD is cars RDD. The data type of this is org.apache.spark.rdd.rdd of strings, because all these were strings inside. So it is an RDD and of strings, and its parallel collection RDD 0 at parallelize console 25. That's okay. So basically we have created an RDD out of it, and the name of an RDD is cars RDD. Now if I want to see the contents of cars RDD, I can do it by cars RDD collect, right? So if I want to see the contents of cars RDD, I have to do it by cars RDD dot collect. Again, I'm getting this stage 0 and stage 1 and all this. Better I do is set log level as error so that it doesn't show me all these things. Okay, so if I do a cars RDD dot collect, it will just give me a result. So this is how we create RDD. Just copy it above and remove this. So to start, Spark shell, and you have to do these two things always.
What is a Spark session actually?
Okay, so we discussed in the previous thing there are two things: Spark context, which gives you the entry point into going into a Spark session, and Spark session is where all these codes are executed. So every time you do anything, there is a session created, and name of a session is a Spark session, right? So that this is the name of a session, Spark. So you see over here that the Spark session is created as a Spark, and Spark context is created as SC. So Spark context is a way to communicate anything with a Spark session. So Spark session is where you are executing. So this is basically a Spark session for you, whatever you are running over here. And the Spark session for this is available with a prefix as Spark. So whenever you want to use anything, you are going to do as a Spark context. So this is a session dot a context. So context is a way to interact with the session, and session is something that is running in front of you. Okay. Any questions over here?
At this stage, when we created an array and then further we created this RDD, how are these two different as of this stage?
Uh, Array is a default data structure for a Java or Scala, right? So when
Mm-hmm.
we create an array, array is not distributed. It is only present in this machine. So all this data is present in a single machine, single place, right? So it's a single array. And when we are creating a cars RDD, this is just a different data type. So there is also a data type array. This is the data type RDD. Array is present in a single machine. RDD is present or spread across multiple machines. So in our case, since we are doing a parallelize of two, it will be spread across two machines or two executors.
Okay.
Does it mean that when you created the array, it is only in the driver
Yes, array is
and the
only in the
RDD?
driver. Yes.
Okay, and once we created the RDD, that will be distributed in the executor as well.
Right.
Means the executor get it the data basically.
Right. Right. RDD will be with executors. Right.
Okay.
Okay. Perfect. So this is how you create an RDD, which is the simplest thing to do. Now again, to create an RDD, we use spark.spark context.parallelize. Instead of using a spark.spark context.parallelize, you can also use a SC. So you could have also used instead of spark.spark context, you could have also used sc.parallelize. So it will also do the same thing. So basically save certain line of a code, right? So you can also do sc.parallelize. So I will just copy over here, and you can also do a sc.parallelize. We'll just highlight that we are doing a sc.parallelize, whereas over here we were doing a spark context. So it is pointing basically to the same thing. Okay, let's go ahead and let's see first transformation. We are going to start with the transformations. So transformations is used to basically modify some data. The first example of a transformation is, let's talk about distinct. So I have made a cars RDD, and if I want to, let's say this cars RDD is not having any duplicate values. Let's say I want to put some duplicate values over here, and let's say I put a BMW again. And I see that there is a duplicate value. So this BMW is present two times. So if I want, since the BMW is present over here two times, if I want the distinct car names, I can use a distinct method. I can use a distinct method. So to use a distinct method, I will say that val distinct cars RDD is equal to, what is the original RDD name? What is the original RDD name?
Cars RDT.
Cars RDD. So cars RDD. And for distinct, since we are doing a distinct transformation, it's obvious that the name of the method will be also distinct. So what will this do? This will do nothing, but it is going to give all the distinct value inside the distinct cars RDD. So this was having BMW two times, but this will have BMW only one time. So if I see this distinct cars RDD, to see the method is collect, so it will show that distinct cars RDD dot collect, and you can see that BMW is present only one time. Reason being, you applied a distinct method, so the BMW is present only one time. So let's just copy this. Any questions in this so far? So we have applied a distinct method. So let us write some notes as well over here. So what we did over here, create an RDD with some distinct values. In our case, we have kept with some duplicate values. So we have kept it BMW 2 times. Then after keeping this, this was an create an RDD. So this is these two steps, and we saw that it is created. After that, the next step was get distinct values in RDD. That is, BMW should only come one time. So you can see that after doing a distinct and once we did a collect, the BMW was present only one time. Any questions in this so far? Any questions? No questions? Okay, let's go ahead. Then let's go for a next one, that is 2 dot what? 2.2. 2.2 filter. Let's say I am having this cars RDD. I am having this, let's say, distinct cars RDD, and I only want the cars that are starting with the word B. So I want only the cars that starts with the word B. So if I only want the cars that are starting with the word B, I will have to apply a certain filter to it, right? I will have to use some where condition, or I will have to apply certain filter to it. So since I want only the cars that are present with the word B, so I will say that distinct cars RDD dot distinct cars RDD dot, the method name will be obviously filter. So I am saying that for a distinct cars RDD, do a filter, and there were multiple cars over here, right? So let's just say that it is something, I have to just give a arbitrary name for it. So I say that it's a car names. For every car name, so for every car name, I will have to do is car name dot, I will explain once we write it, starts with B, right? So what we are saying that for a distinct cars RDD, so distinct car RDD is nothing but these things: BMW, Mercedes, Jaguar, Fiat, and everything. Distinct cars RDD, we want to filter something, so we are writing filter, and in filter we are saying that car name, that is it is going to take each and everything in a given car name. So it is going to take a car name. So BMW will come in a car name, then Mercedes will come inside this variable car name, Jaguar will come inside this variable car name, Fiat will come inside this variable car name, and it is going to check that is the car name starting with B. So if it is starting with B, then only it will going to filter it out. And I will just do a collect so that I can see it on the screen. So I've written this collect so that I can see it on a screen. So again, let's understand, this is the name of an RDD. We are passing to a filter method. We are passing it to a filter method. In a filter method, for each of the variable, you will get a BMW, Mercedes, and everything in this particular car name. And we are filtering only the one that is starting with a B. And we are using a collect behind so that it displays on the screen. So you can write multiple functions behind main. So this will be applied this function. Once this function is applied, this function will apply, and so on and so forth. So let's press enter. So the cars that were starting with were BMW and Bentley. So uh, it's over here, right? So any questions on this filter?
If I need to that's for the start. If I just need for like B any percentile or W. So how we do that thing means
You want to do it like B should be present anywhere, is it?
No, starting with B, having a second word or any number of words,
Yeah, you
and
can
ending
just,
with
I think
W.
so, you can just write BM, right? So if you write just BM,
No,
then it
no,
will,
no.
okay,
I'm just saying like starting with V and ending with W. That's all.
okay. So let's see if there is a method called as a ends with. So if there is a method called ends as a ends with, you can just apply this ends with method. So if you want to check what are the methods, let me just try. If it is there, then it may work. But I don't think so. Ends with is one of the methods that is available. It's not there. So you can check if there is a method available or not. If there is not
Okay,
a
okay.
method, then in that case, what you will have to do is you will have to write a function by yourself and define a
Mm-hmm.
function, and inside a function, you will have to write a logic for it.
Okay.
So we are going to write another function for this after this.
Sure.
Okay.
Thank
Any
you.
other questions?
These all functions comes in with Spark only, not Scala, right?
Yeah, this
Or
comes with.
they are Scala functions.
I mean, the similar functions are also available in Scala. Is the first thing.
Okay.
Second thing, this starts with is a Scala function. It's not a Spark function. I mean, it
Oh,
can be a Scala, it can be a Java. Scala is nothing but on top of Java. So this is a
okay.
Scala function only that is getting applied on each and every element. So you can
Okay.
define, if you want to see what are the functions available. I can just define uh, car name as a some variable, and I say ABC, right? So this is just a string, right? And I just do a car name dot and a tab button. So if I do a car name and tab button, it should give me all the functions that are available. So if I do a this button, then you have the function called as a starts with, right? Similarly, I don't think so. There is any function that is end with. So if there's not a function, then another thing that you can do is you can just look over here. There is something called as a reverse. Then you apply a reverse, and once you apply a reverse, then you do a start with. So it will
Yep.
work for you.
Sure. No worries. Thank you.
Okay. Oh, there is a ends with also function. Then why it did not work? Ends with is also there.
Maybe you write E as a caps. It's a case sensitive language.
Yeah, it's a case sensitive for sure. But did I?
Yeah, you put it and as caps. I think E and caps.
Oh, I put E in the caps. No, E is in small. ENDSWITH. So what's the reason? ENDSWITH. So if I just remove or start with and I just put ends with, then it works probably. Then it works. And probably you cannot do two things because you already done probably because ends with is giving something. So let's say you still want to implement, then what I do is,
Was there an extra bracket, closing bracket that you do?
oh, is it?
I'm not sure. Yeah, no, I'm not. I just want to check. I'm not sure.
Okay, so I mean, okay. Then what we can do is, I mean, just put starts with B and put in a val a RDD is equal to starts with B and val B RDD is equal to
Ends with
ends with W, and it will be applied to a ARDD now, then do a BRDD
collect.
dot collect. Okay, fine. So this is about filter, how you can filter out few things. Now let me again just go back to the previous thing that we discussed. So we said that this was the contents that was present, distinct cars RDD dot collect, and then we said that we want to apply a filter. So we got everything that is starting with a B. Now this car name, instead of car name, you can put anything, right? So you can put anything instead of car name. You can just say that X becomes X dot starts with this, right? So in that case, if you want to do this, uh, there is also another way. I mean, you can change this car's name to X. It will still work, right? X become X dot starts with B. Again, to make it small, you can just replace it with underscore. So you can just replace it with the underscore. So this entire part, because this conveys no meaning, this is not conveying any specific meaning, right? Or you can put any variable name, it has to be same thing. So you can just simply replace it with a shorthand notation, that is a underscore, and it will still work. So this is called as a shorthand notation that we have studied in Scala as well. So you can also do it as a shorthand notation. So this is called as a shorthand notation. Use shorthand notation. Okay. So this is my example number 1. Let's see another example. Okay. So this time what we do is we will just define certain numbers, and we are going to filter whether it is an even number or an odd number. So to define RDD, let's say I'd say it as a val numbers RDD is equal to. So can you give answers to me as well along with why did we put a val not var?
Just to make
Immutable
it
or
permanent.
immutable?
Because numbers RDD is anyhow an immutable data structure.
Immutable,
So
yeah.
you should also always use with a val. However, even if you use with a var, it will still work, but you should not use it. Then to create an RDD, what was the method?
SC dot parallelization.
Parallelize. Okay. And since I want to put some numbers, I will put some 1 to 10 numbers. Okay. So I just say that I want 1 to 10. And let's say I want to put it in 2 partitions. So I give up
Comma
2
2.
partitions.
Yeah.
This specifies it's a 2 partition. How do I see the contents inside this?
You can
Number
collect.
RDD dot collect.
Numbers RDD dot collect. So collect is a transformation or an action?
Action.
Action, right? Okay, perfect. So collects is an action.
If we use the var for the RDD, then the var behavior will be not working because it is RDD.
Right, right.
Okay.
Yes. Okay. So we have created an RDD 1 to 10. That is the contents inside it. Now let's say I want to do some filter on it, and I want only even numbers. So if I want to do a filter on it, numbers RDD, what will be the method? For filter, what is the name of method?
Filter.
Filter. Okay, perfect. Then since I'm doing a filter on an RDD, I want to operate on each and every element that is present in this RDD. Right? This is one element, this is two element. So can I just take some arbitrary variable and say X becomes X? Okay. So I want to filter in such a way that I get the even numbers in it. What do I want? I want a even numbers. Okay, I want a even numbers. So let me say that since I want a even numbers, I will just say that I want to put in an RDD whose name is even numbers RDD is equal to numbers RDD dot filter X becomes X. Okay. So what I'm saying that numbers RDD, I want to apply a filter. And how do I determine whether a number is even or odd?
Not to zero.
It should be divisible by 2, right?
Yeah.
I say x
Percentage 2
modulus
equal
2
to 0.
equals to 0. So you have to write 2 double equals 2. Okay. So so that it means that it is comparison of equality, not assignment operator. It's a equality comparison operator. So you have to use a double equal to. So it says that filter the contents of numbers RDD uh, wherever x is x modulus 2 equal to 0. And how do I check whether it worked or not? How to see the contents of it?
Collect it again.
Collect again. So collect again. Again, if the bracket is empty, you can also skip brackets. It will still work if there is no parameter. So even numbers RDD dot collect 2, 4, 6, 8, 10, and you got an even number out of it, right? Any questions in this? Okay. If no questions, then can you say me for a shorthand notation what should be changed?
Replace x with underscore.
So complete x equal
Yeah,
to greater
underscore.
than with an underscore. So
Yeah, that should work.
it's shorthand notation, and uh, it's collect over here. So it's giving the same result over here, right? Any questions over here? Okay. If no questions, then let's go ahead. And let's say if I had to implement some complex logic over here, right? If I had to implement certain complex logic over here, if it is a simple logic, I can just write it over here. Even if it is a complex logic, I can still write it over here, but it won't look very good. So if it is a complex logic, what you can do is you can define it as a separate function. Okay, if it is a complex logic, you can define it as a separate function. Like the previous case, it should start with b, end with w, and blah blah, length should be 3 and whatever, right? You can still do it over here, but it will become very complex. So what you can do is you can define as a function. So let's say I want to define the same logic of even number and odd number inside a function. Then to define a function, the keyword is def. Def stands for I am defining a function. Let's keep the name of a function as even filter. So what this even filter will do is, this even filter is going to take all the numbers one by one, and it is going to just filter it off the number and finally give you the result, right? So basically I have to implement the same logic. X modulus 2 should be equal to 0. So this is the logic that I want to implement over here. So even filter, so this is the function that I am defining, even filter. So when I am defining over here, what does a filter, what does a function have? Function has some input parameter and function has some output parameter. So can anyone say what should be the input parameter for this when I apply over here? If I'm going to apply on a numbers RDD, what will be the input parameter?
Integer.
Integer, right? Because it is an integer, right? 1, 2, 3, 4, 5, 6, 7, 8, 10 is integer. So the input parameter is integer, right? So input parameter is integer. Output parameter will be true or false, because true or false. True means you have to filter it out. You have to pass it. False means remove it. So the output will be a Boolean value, but no need to say output because Scala is intelligent enough to understand what is the output. So no need to just specify what is output over here again. So what I'm doing is define the even filter as the name of a function for which we are taking x as a input variable. Now what I have to do for an even filter, we have to just do the same thing, x modulus 2 equal to 0. Okay, x modulus 2 equal to 0, and press close the function, right? So it gave me certain error, and anyone can say what is the error? Anyone who can say what is the mistake over here?
Capital I is missing. It
Capital
should be
I. So
capital I.
instead of small I, it should be capital I. But why it should be capital I?
Because it is an object-oriented language, it is the best class.
Right.
Or yeah.
Right. So it is not like a Java. Though the Java is set to an object-oriented language, it is not a pure object-oriented language because it has a small I in int. That means it is a primitive data type, right? Small int is a primitive data type in case of Java. But in case of Scala, it is a pure object-oriented language. So I is not a primitive data type anymore. It is a class and object. So you have to have a capital I. Okay, good. So x modulus 2 and it should work fine. So what you have done is you have defined a function over here that takes an integer as an input and it does nothing but x modulus 2 equal to 0, and it should be returning a boolean, and boolean should be either a true or it can be a false. And let's say I want to apply it again to a even filter, so I will say that val even numbers RDD is equal to numbers RDD dot filter and instead of just writing a logic over here that we were writing, instead of writing a logic I will just write a function name. So instead of writing the logic, we are just writing a function name. So you can either write a logic directly over here or you can write a function's name of a function. And I do this. And to check the number, check the output, the thing is even numbers RDD dot collect. So it should also give a even numbers, right? So over here, if you want to implement whatever crazy filter you want to implement, you can just implement over here. You can just say x modulus 2 equal to 0 and it is not equal to 4, whatever, right? So you can just write whatever Scala you can just write over here. Any questions over here? Okay, if no questions, then let's copy over here so that you can refer it later on, and just write certain things so that it's easier for you to follow. So defining an RDD with numbers 1 to 10 in two partitions. Then after that, we just filter. If you want, you can just practice with me as well. Filter only even numbers. So you are filtering only the even numbers, and it's the same thing. Over here, we did a bit different. Is use shorthand notation. So you use the shorthand notation over here, and for more complex filters, prefer to use this. Okay, so for more complex filter, I prefer to use this. Prefer to define function separately. So if you want to do this, you can prefer to define a function separately. Okay, any questions, anyone? So it's good if you have two machines or two laptops, you can keep the video running in one place and practice in another place. Or okay, any questions so far in filter? Okay, no questions. Then let's go ahead. And
Uh, um,
yes,
can we collect in the single line in the when you are filtering the even number RDD?
yes, you can collect, right? You just give over here dot
Yeah,
collect.
I'm getting error. That's why.
You can just write collect
Or
and
I
it should
missed.
work.
Oh, okay, okay, it is working. Okay, thanks.
Okay, perfect. So unless and until, I mean, whatever is the output of this is able to, this collect can take, so it will work fine. But in the previous case, like we were doing an odd and even number, starts with and ends with. the previous output cannot be fed into a next output, then it won't be work. Okay, so let's go to the next one, and let's look into the RDD that we have. We had distinct cars RDD, and let's see what was the value inside it, because we may have forgot looking into numbers so far. So this was the contents of distinct cars RDD that we made a while back, and we want to make some mapping with it, right? So map is one of the functions or methods that is extensively used. So what we are going to do over here is we are going to just select only the we are going to do the same thing like we did for selecting only BMW starts with B. We are only going to do the similar thing, but now we are going to use a map function for it. So let's see an example of a map. So I will say that we are going to filter all the cars that are starting with B, that is BMW and Bentley, and but using a map function. So we'll say that val cars with B, okay, val cars with B RDD is equal to the input RDD is distinct cars RDD. So I will just write distinct cars RDD dot. So you can just write half the things and press the tab, so it will auto complete for you as well. So we are saying that distinct cars dot RDD, and since we are working with a map function, obviously we are going to apply a map over here. And what will this map work is map will work for each and every element inside this, right? So I will say map, and I want to run on each of the car names. Okay, so it says that I am going to run for each of the car names. So for each of the car names, we are going to make another collection, and which will have whether the what is a car name and whether it starts with B or it doesn't starts with B. So I will say that car name becomes car name, comma, car name dot starts with B, right? So let's try to understand what it does. It takes the RDD, that is this RDD, that is it takes this particular RDD BMW, Mercedes, Jaguar until Audi. It takes that RDD, applies to a map function over here. For each of the elements BMW, Mercedes, Jaguar, Fiat and so on will come in this car name, and it will be transformed into a combination. So I put a bracket over here, and the combination that will have a car name, that is it will have the same car name, comma, car name dot starts with B. So if it is starting with a B, it will have a value as true, and if that car name doesn't starts with B, it will have a value as false. So let's execute this, and let's say cars with B RDD dot collect. Okay, so the cars names that were having uh, B, that will become true. So you can see that BMW is true because it starts with B. Mercedes becomes false. It starts with doesn't starts with B. Again, Jaguar becomes false, doesn't start with B. Bentley becomes true because it starts with B, right? So you are basically doing a map function, and you're trying to do the same thing, making a car name and starts with B. So you are having a BMW and true, Jaguar and false. Once you have this, again, since you want only the BMW, you will apply a filter now, and you will say that cars with B RDD dot filter. So again, for a filter, each of this element will be iterated at a go. BMW and true will come together. Mercedes and false will come together, Jaguar and false will come together. So I will say that X becomes, okay, something. So I am taking X. So I have to take for each and every X. And I only want to filter out the true. I only want to filter out the values 2. So I will write X dot underscore 2. Dot underscore 2 meaning I am referring to the second element. I am referring to the second element. This is the first element. This is the second element. So I will say X dot underscore 2 is equal to true. Okay. And finally, I will say that collect. So what this will do is it is going to take this cars with RDD and it is going to apply a filter function and it will filter all those things where the second element is true. So the second element is true over here and here. It is going to take for each and every element, check only the second element. Is it equal to true? If it is equal to true, then only it will take and it will do a collect. So it is going to uh, make a BMW and true and all, right? Any questions in this so far? Anyone? Any questions? So I'm saying we are making a car name and true slash false. So we are whether it is starting with a B or it is not starting with a B. So we are making a true and false. So map, then cars with B. We made a true false over here. Then over here we filter only the true one. Filter only true. Any questions over here? Okay, if no questions, then can you suggest this is having a okay. I want a distinct cars RDD. I am having a distinct cars RDD. Can you suggest what code I should be writing using a map function so that I get a car name and the length of that word? Okay, I want to use a map function to get the car name and the length of it using a map function, right? So can you suggest the code? Can you suggest what shall I write over here? I want the output should be something like this. I want the output to be something like this. If I have to write the output over here, I want something like this. BMW, comma 3. Then I want Mercedes, comma whatever it is, 8. 1, 2, 3, 4, 5, 6, 7, 8, whatever. Comma 6. Something like this. Comma 4. Honda is 5. Okay. I want some output like this. So can you suggest what will be the code? Map function.
X equal to x comma x dot length.
Okay, so first I have to write this distinct RDD name, right? Distinct cars.rdd. What is the function that I have to apply?
Map.
Map. And once it goes for a map, the map is going to execute for each and every element. Okay, map is going to execute for each and every element. So the first element it will take is BMW and it will execute something on it. So what shall I write over here?
X.
Sorry?
X rocket.
X, okay,
Rocket, then X, comma.
okay,
Length of the X.
okay. X dot length.
Length.
Yeah, something like that.
Okay. So any other thing that I need to do over here?
Then collect.
Okay. Then collect so that it appears on screen. Any other thing?
Should.
Any other thing over here? Something missing? Okay, let's execute. So it gives me an error. Then what shall I do? Can you try to interpret it? What is the error?
Okay, there's a bracket missing for x comma x dot length that should be within bracket.
Okay, that's a good thing, right? Because it is not able to understand some parameters as well, right? So x dot length. So x becomes x dot length. Is it clear? Because it was not able to understand x becomes x, then comma. Okay, it just understood, okay, x becomes x. Then what is this? It doesn't understand what is this. So everything should be bracket. So it says that x becomes everything like this, a bracket, right? So uh, it's okay to go wrong, but to interpret the things is more important. So any questions in this, anyone? So example 2, wherein we make a example 2, car name comma length of car name. Example BMW comma 3, right? Something like this we want. Any questions in this so far? Any questions in this so far?
No.
Okay, then we are done with 2.3 as map. Let's go to 2.4 as flat map. Okay, so let's do a flat map in Scala itself first, and we understand what it is doing, and then we see what is a map, right? So we are not doing in Spark. The way how Scala works and Spark works is almost everything is same, right? So I'm just defining an array in one dimension, as I'm defining an array. Okay, so 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. Okay, so this is the array that we have defined. So it's difficult if you type during session. So while array 1D is equal to array 1 2 3 4 5 6 and 7 8 9. It is basically an array of a string, because this is one string, this is another string, and this is another string. So it says that it is an array of a string that we have defined. Now let's apply a map to it. While array 2D is equal to array 1D dot map. So we want to apply a map function to it, and I say that for every x it becomes x dot split, and I want to split it with the commas, right? So what I'm doing over here is I want to split with the commas. So what this will do is it is going to split this comma and this comma. Okay, so what's the mistake? What's the problem? Not found 1D. Okay, so okay, it was a D was a capital. Let's do again so that it's easier to follow. Home delete val 1D and val 2D. Okay, so I've defined an array in a over here 1 2 3 4 5 6 and 7 8 9. When you did a split over here, you did with the split as a comma, it was separated into 1 2 3 4 5 6 7 8 9, right? So that's what a map function will do when you are using a map on it. Similarly, what you can do is you can make another flat array, and instead of a map function you can apply a flat map. So what this flat map does is, instead of having an array of an array, it gives you an flat all the elements, right? So instead of giving you an array of an array, it gives you all the elements together. That's a flat elements, right? So this is how you can use a map and flat map on the array elements. So what is the difference in a map and a flat map? If you map can return you sometime array of an array, but when you return a flat map, it will always flatten everything out, right? So this is very important thing. Sub also one of the interview questions, possible interview questions, that what is the difference between a map and a flat map? So flat map will always give you a flattened structure, but a map can have a nested structure as it was there in this case, right? Any questions in this?
So output of flat map is always a one-dimensional
Yes,
array.
output of a flat map will be a one-dimensional array, right?
Okay.
Okay, so let's write something and let's do it in terms of an RDDs. So let me define a certain book. Okay, so let me copy some contents from internet to define this. Book text. Okay, so let me just copy certain text from somewhere. Okay, let me copy this one. So these are the three paragraphs, and I just copy in a notepad. Okay, so I just copy in a notepad. I just don't copy it directly because of some special symbol. It may give me some problem. So let me define it over here. Okay, so I define it as three different paragraphs. Okay, so this is some contents that I have taken randomly from internet, and let's copy this content and let's define it as a book. So val book is equal to array, and inside the array, but it's not able to paste. Let me in fact take some more data. The data will be a bit less for us to play with. Let me take more data, and I just enclose delete delete. Okay, let me copy this and let me paste it inside the arrays. So paste. Why it doesn't take? What's the problem?
You can try right click. No, like clipboard didn't copy it.
Maybe because of lot of data. Let me try till here first. Copy, paste. Okay. Maybe lot of data it is not able to copy. Let me try some more data. not so much. Let me try till here. Copy, paste. Oh, not even this much. Paste. Or else, let me just shorten this thing because it will be a lot of problem if I. So let me shorten this text a bit. Okay, then shorten this text, shorten more, and I hope it is able to copy this much at least. Copy, and I say val book is equal to array, and right click paste. What's this? Cannot even copy this much.
Is it possible to write, means store it in a file and then read as an array from there?
Yeah, but it's just that I mean it's not able to copy between VM and outside the VM. Probably maybe the limitation of this Oracle VM.
There might be. Then we can copy this,
Okay,
open a notepad in the file in the VM itself. Huh?
right. If I'm not able to copy it back to this document, I will do that because I want to just make this document also for you guys to refer later on.
Yeah.
Perfect. So we are done with the example one, and we wanted to play around this map and flat map uh, in RDD, right? This example one was in Scala, and concept is same. This was only in Scala, and this is we are doing in RDD. So what we did over here is we defined a val book array, and this is the contents in an array, right? This is contents in an array. It is an array of a string. So there are multiple strings present inside it. This is my first string. This is my second string. This is my third string. That is my fourth string, and this is my fifth string basically, right? So I am having five strings over here, and we are going to work on this particular text data. Reason for working on this kind of a text data is what is the first program that you write when you run any when you learn any of the programming language?
Generation new process. I
Sorry,
have not seen a single
sorry.
word count.
Word count, word
Yeah,
count.
word
No,
count.
in Python, in Scala, in Java. What is a
Hello world.
Always the
Hello
hello
world.
world.
hello world,
Hello
right?
world. Yeah.
So we write the first program that we write when you're learning any of the programming languages, print a hello world, right? Any reason why we write this program?
I think the input, check the input output, how input output works,
No, it brings a good
interactivity.
luck. It's bring a good luck for programming. Okay, just kidding. So, you whenever you learn any of the programming language, you always write a hello world program. And similarly, because that's the most basic thing that you can do with any of the programming language, the simplest thing that you can do in any of the programming language. But since Hadoop or Spark, or let's say any of the distributed data processing engine, that you will be working on, the first program that you write is a word count. Be it a Hadoop using a map reduce, or be it uh, this one, the first program that Spark you write is a word count. What do you do in this word count program is you basically just count how many number of the times the appeared, right? So let's say the appeared 5 times, 3 times. History appeared 2 times, right? And off appeared 5 times in the whole document, right? So this is the first thing that you ever do while you are writing any of the programs in Big Data, Hadoop or Spark. Why we write this program is because in Hadoop, it doesn't make a meaning in writing a print hello world for a distributed programming. What will it signify? That the hello world is getting printed in a driver program? That's it, not more than it. You want to do certain kind of a distributed processing. The processing that should happen in multiple computers or multiple nodes. So the most simplest or the most basic thing that you ever do in a distributed programming is a word count, because let's say this is an now it is an array. We are going to convert it into RDD shortly. So this array, once you convert it into an RDD, right? Once you are going to convert this into an RDD, it will be stored in a different machines. So let's say this sentence will be stored in a first computer. This sentence will be stored in a second computer, and this sentence will be stored in a third computer. So there will be a lot of processing that will be happening in first computer, second and third, right? And then you have to probably aggregate everything into a single place. Either you aggregate directly into a single place, or somehow you aggregate and come up with this count, right? So this is the reason that whenever you are studying any of the distributed processing or a distributed computing, you're going to study it on a you're going to study it on you're going to study, or first thing that you're going to do is a word count program, right? So the first thing you are going to always do is a word count program. So luckily I'm going to able to copy from here to here. So what I have done over here is we have just defined an array that was an book, and this is an array now. Since it is an array, it means that uh, it is present in a single machine. Now I want to convert it into an RDD. I want to convert it into an RDD. So can someone say how do I convert it into an RDD?
Well,
Well,
book RDD
RDD is equal to
equal to Spark context dot parallelized
parallelize
with the array
with the array.
and book array with the 2 or 3, whatever the
Okay, whatever partition we want. If
yeah,
you don't specify,
partition
it
we
will be
want.
one partition. Okay. So this is how you create an RDD. So you have created an RDD. So the difference between this array and RDD is like it is having the same contents. It is not having anything different. It is having the same contents, but it's just that it's an RDD and it is having a two partitions over here. How do I see the contents of this RDD?
Book RDD dot collect.
Book RDD dot collect. Okay, so book RDD dot collect is going to show me the same thing. Once it comes on a screen, obviously it becomes an array to show you on the screen, right? But book RDD is not an array. Book RDD is an RDD, right? Book RDD is an RDD of type string, but you're displaying it becomes an array. Okay, fine. So you have created an uh, book RDD, right? So next thing,
I have one confusion. Can I ask?
yeah, yeah,
Sorry.
sure, sure, sure.
When we did the collect, it send a action message to all the executor to collect the data and give back to the driver. Am I right?
Right.
Yeah. And then so it collected as a RDD, but when it is displaying outputting to the client machine, it is array. Why?
That is array. Why? Why is the question? Is it?
Yeah, exactly. So, but internally it's collected as a RDD. But
Right.
when it is basically the displaying, outputting, it converted back to array.
Right. So
That is the
RDDs are
reason.
distributed. If you want to, I mean, if they wanted to keep it as RDD, then they would have to display it into a different machines that you won't be able to see. So it's basically the simple reason being because the collect method, whoever has written, he has kept a return type as a string or array, right? So if I want to see this, then what you can do is you can just open Google, okay, and you say Google, and in Google you say that GitHub Spark collect, okay, just say that GitHub Spark collect, okay, so that you reach into a Spark repo. So this is Apache Spark repo, okay, uh, but it's not actually pointing to the correct place. So let's come into a GitHub Apache Spark, right? Go to a GitHub Apache Spark and write collect. So you see a collect. Okay, this is collect is used. Somewhere a collect function should be defined, def collect. So many places. Uh, so you go like this 1, 2, 3, 4, and next, and hopefully you are able to find that collect method somewhere. And you will over there you will see that a return type is a array. If I search for a def collect again, it is showing me all the defs as well. And obviously the repo is very big, unable to find directly. Def collect, okay, good. So this is a def collect, this is a function definition for collect, but it is in SQL. Any other collect you find? So org Apache Spark, let's say, let's go into an uh, org Apache, okay, maybe inside core, where should be the RDD? Core, source, main, okay, Scala org Apache, then go into RDD, okay, then in RDD again, how I am supposed to find the collect, where the probably in rdd.scala, is it a collect method? Def collect, okay, so here is the thing, right? So we are able to find it. So if you see this function definition for def collect, you see that the return method is array, right? So it's because that the collect function is having a return type as array, so it returns you as an array, is the first question. Is the answer why it returns as an array, and why they must have otherwise if they write it as a RDD as written, then you cannot see it. I mean, it's again a distributed.
Yeah.
Any other
Thanks.
questions? Okay, so if no other questions, then let's go ahead. So what we did over here is we did a collect, and we saw that uh, it's an array of a string after displaying, and this is the contents that is present in an RDD, and we made an RDD of a 2 parallelize, right? Parallelize as 2. Now let's run a map function on it, and what I want to do is, if I want to do a word count example, if I want to do a word count example, what are the steps to do a word count example? Can anyone just give me rough steps for word count example?
Means in Scala
Anything, I mean,
or
not it should be just English language. I mean, what will you do? Given this word, how will you count it in some algorithm? You have to write some algorithm to count it. So how will you count it?
Split the
Sorry.
split the word after any space and
Okay.
put a counter on it.
Okay.
Means
Split.
if there is a space, then count equals to means variable increase the counter as one by
Okay.
one and then move ahead.
Okay.
So till the time he does not found the space, it's count as 1.
Okay.
Means
No, I want
as
the
soon
count
as
for each of the word, not the total number of words. I don't want the total count. I want how many times the is present, how many times history is present, how many
okay.
times off is present.
First, we need to collect all the tokens or the strings. Then we have to group by those tokens, so it can be give the counts.
Okay, then do a group by.
Group by, yeah, group by. So it can be counted how many times is every token is appearing.
Okay. Okay, perfect. Somewhat one more step will be there. That is, first will be a split. So you'll just split every word. Assign value 1 to every word. Okay. Assign value 1 to every word. So it becomes the 1, history 1, and just reduce it so that the becomes 5, history becomes whatever 3, right? So these are the steps. The first step that you will be doing is you will be separating each of the words by spaces to make find each of the words. Then assign the value 1 to it, and then just sum it off so that you get the total. The is present 5 times, history is present 3 times, and so on, right? So any questions on this? Okay, no questions. Then let's go ahead and let's try to split it by words, split it by spaces. So if I want to use a map function, book RDD dot map, okay, I'm doing a map. And if I'm doing a map, how is the map working? Is it working element by element?
Line by line.
Right? A line by line, right? Element by element, right? That means for
Yeah,
a string by string,
right.
right? So it will take the first string and do it, and second string and do it, and third string and do it. So I will say that book dot map x will become x dot split, and I want to split by what now? Do I need to split by what thing?
Space.
Split by a space, right? So I want to split it by a space. So I want to split it by a space. So if I want to see the output, collect. Oh, sorry, spelling mistake. Collect. So what I get is the word separated. The history of is the word separated.
No, we have not got single words separate.
It's separated, right?
Yeah.
But what is the problem now? What is the problem over here? What
We
is the
want an
problem?
array of all these words separately. This
Yeah,
is like
we need to use the flat map.
array of group of words. This is
We want only the words, right? But I'm getting an array inside another array inside another array, right? So what is the solution for it?
Flat map.
flat map.
Flat map, right? So that's great. So you know the solution, and you can do a flat map. So very good question for interview again. What is the difference between a map and a flat map? So if I do a flat map, can you see it? It is what I wanted. Is the step 1 done? Is the step 1 done? Is it clear?
Yeah.
Okay. Is the question, is the difference between map and flat map clear? Any questions in this? Any questions in this? Difference between a map and a flat map? Any questions? Okay. So if no questions, let me just copy it back to this one. So you are one step done towards becoming a Spark engineer, a data engineer. you are able to split by word, then you are having two more steps. So this is the one thing that uh, is the most basic thing. So what we did over here, make an RDD from array into partition. So just change it to a different color, and I just see over here. So collect is self-explanatory now. Using map, get array of array, right? So if you use a map, getting an array of an array, this give me some error, is it? Giving some error. So using map is giving you an array of an array, and the solution was to use a flat map, flattens, right? So it will flatten it out. So you can always refer to this. Any questions so far? If no questions, then we are just left 5 minutes so for 2 hours. So maybe we can start tomorrow because we won't be able to complete anything. So